Hello, everybody. I'm Bartek from L2Beat, and every year I have a pleasure of hosting this amazing panel on DA on this summit. So we met last year. We're gonna discuss DA this year. Hopefully next year, it's gonna be equally fun. So I kind of like did a bit of a reshuffling here. Maybe wasn't smart, but we're gonna see. So I put Toggle right next to me because he's supposed to represent Ethereum. I have no idea why, but there's like a tradition on this conference. Last year he did the same, and that's surprising because he's been sometimes I don't know. I mean, let's see what he's gonna say about Ethereum DA, right? But I'm like thinking that he might represent Ethereum here. And then on the other side, we've got two projects. We've got Mustafa from Celestia, and we've got Prabal from Avail. And again, from the Ethereum point of view, I kind of see these guys as being like an external DA provider trying to kill Ethereum's DA roadmap or whatever. So maybe, they like on the opposite side with Toggle. Again, we'll see. And in the middle, we've got Matt representing EigenDA. And I have no idea where EigenDA is, so I just put him in the middle. So we're going to find out, right? So this is a setup, and I put myself right next to Toggle because my background is Ethereum. So I'm really glad that the module people keep inviting me, even though I tend to like take Ethereum's point of view. But we're gonna see, right? So my first question, I guess, to the panel is that last year when we discussed DA. Like every single project was either a white paper or a PowerPoint or maybe a testnet. My main question from last year was like, where do you think the space is gonna be in a year time? And we got some interesting answers. Like I do remember we're gonna see thousands of rollups being in the production or so, right? And I got really scared at that time because at L2Beat, we are trying to evaluate all of them, but so far. Thankfully, we only have like less than 100. But anyway, I want to ask you guys, like, do you like, or how do you see the space 1 year after? I mean, is it where you hoped it to be, right? So maybe I'll start with, the left side of the panel.
Yeah, I think I still hope that your job gets tougher. Tougher because not only we see only Ethereum clones of EVM rollups, but also application-specific ones. So when I say thousands of rollups, some of the types of rollups are not, defined in the as a rollup construct in the familiar world. We have seen, various numbers flowing around, and some of them you might also argue that they are not even a rollup, right? And so how you define a rollup also plays a role. But on the other hand, that's where we would like to be. We would like to be in a place where there is lots of application-specific rollups, and then that's where the scalability should appear.
And in terms of product, the Avail, I mean, last year you were at the testnet. Where are you today?
We are still at the testnet, and we are going to launch mainnet very soon. Yeah.
Mustafa?
We will see 1,000 rollups. We're going to see 10,000 rollups, even maybe 10,000 rollups. I don't think I ever said it's going to be happening in a year, but it will happen. For the next talk, the Modular State of the Union, I actually did a comparison to how many rollups we had last year to this year. And we have an insane amount more of application-specific rollups this year than last year. Last year was something like 10. This year we have something like 40. I did actually went on the archive Wayback Machine to look at the L2Beat's website a year ago and now, and there are a lot more rollups. And the main difference is what's happened is that this year, there were 0 blockchains that supported data availability blobs. 0. This year, there's 3, EIP 4844, Celestia, EigenDA. And because now we have more blob space, we're seeing a huge influx of developers deploying rollups using rollup as a service providers like Conduit, Caldera, Gelato, and the likes. And there's literally hundreds of rollups in the pipeline with those rollup as a service providers because they make it so easy to deploy a rollup. So whether you like it or not, it will happen.
Matt, like I said, I mean, I put you in the middle because I don't know. I mean, are you guys building an external DA solutions? Are you aligned with Ethereum? Are you like part of the Ethereum roadmap? I mean, where are you with your solution? And are you live as a product?
We are live.
What are the rollups that are using EigenDA?
And we are currently doing 10 megabytes per second on mainnet.
For something.
So, appreciate it. All right, you can hear me now?
Yeah.
Yes. To confirm, we are live. We launched live Q2 mainnet, and we're doing 10 megabytes per second. And EigenDA is a data availability layer. It's not a blockchain. The focus is for data availability. And yeah, current rollups that are using, whether they are at testnet, moving to mainnet soon, might be like layer N, a team like Celo. We've got a variety of rollups, but also non-rollup use cases that are of interest. Essentially, like data availability is useful for things that you want to make publicly verifiable. And we see that there's a massive space, obviously, in the rollup space and the abstractions that have led from like things like rollups as a service. And we expect the demand for rollups to increase and hopefully continue to accelerate on that front. So look forward to it. And
in terms of alignment, do you consider yourself to be like a competition to Avail, Celestia, or are you trying to like, find the middle ground between, I don't know, who is your primary user? Are you competing with Ethereum or you're aligned with Ethereum? I mean, how do you like position yourself?
I wouldn't say that, like, I think generally you have different options, right? And data availability is like an key operational aspect of rollups and other services. So it's a data availability layer that is generalized and can be used for anything. And as far as on the alignment side of things, I mean, I guess we're secured, inspired by dank sharding. So what that means is horizontally scaling. And so for us, decentralization means that we can get increased throughput and increased scaling. And on that front, we're secured by Ethereum, so over 3 million Ethereum today, as well as like Eigen token, right? So additional quorums. So I would view them as it's an option that applications that within the Ethereum space, it can make a lot of sense working within, but also non-Ethereum like rollups at use cases. If you have anything else, yeah.
Togrul, I see you're itching for, some hot take here.
So firstly, I would say Ethereum is actually secured by Ethereum, unlike everybody else here. And secondly, I think I hope that we don't get 10,000 rollups for your sake as well as for everybody else's sake. I think the meta of dying L1s becoming L2s is dying a bit, so they're going to become dying L2s soon. There are still going to be quite a few general purpose rollups, but I think the future is shifting more towards app-specific rollups. Again, I'm not sure how many you actually need, how many use cases need their own block space, but there are certain reasons why you would do that, and there are even L2s popping up on Solana now. So I think the future is more correlated to app-specific rollups rather than people just launching 27 other OP stack chains that have basically nothing different to every other OP stack chain.
So it seems to me that we are all betting on the future need, in a way, for abundant block space. At least some of us are. And today I've checked that the price of posting data to Ethereum is actually surprisingly cheaper than posting to Celestia. I'm not really sure. Like it fluctuates a lot. Sometimes it can be quite high, and sometimes it's just like next to zero. So I can definitely understand some people saying that we need to focus more on apps and not the infrastructure, right? And you probably must have heard these types of comments. We're building a lot of potential blob space. Are we like hoping that that's going to enable new use cases, or it's just too much at the moment, and we should, like, as a community say, hey, with that much blob space, maybe we should like focus more on applications. I know that you, Mustafa, you kind of like, had some take on that recently on Twitter. So what do you think? I mean, do we actually need that much blob space, considering, especially from the Ethereum point of view, that Ethereum very soon is going to introduce peer DAS, right? That's going to like increase quite substantially the amount of blob space available on Ethereum, and like Ethereum is moving really, really fast, in this direction, right? And at the same time, I've just seen that Celestia has promised, amazing amount of blob space. Same with EigenDA. So like it's a lot, right? And it seems like we are building for some future world, but is that future world's gonna like come soon, or?
Yeah, so first of all, it's not true that Ethereum blob space is cheaper than Celestia right now. If you look at the data, it's the other way around. But in terms of block space, the way I look at it is that I look at it in terms of induced demand. Now, as I said on Twitter, I think what you're referring to, I asked the question is, why is it that 16 years later, since the creation of the Bitcoin white paper, the original use case of crypto, which is payments, we still haven't achieved wide-scale adoption of that. Like, Venmo is newer than Bitcoin, but Venmo has succeeded more than Bitcoin, at least in the US market, at payments. And I think a lot of that does have to do with the supply of block space, because if you look at what happened in the early 2010s in the Bitcoin ecosystem, for example, there was this whole movement where like Bitcoin never had this narrative about being a store of value. The original narrative was that everyone's going to be using Bitcoin to pay for coffees and for payments. And then what happened is that the Bitcoin community convinced a whole bunch of people to start accepting Bitcoin for payments. Even Microsoft accepted Bitcoin payments for things like Xbox games. And then what happened is around 2013, 2014, the transaction fee skyrocketed, and retailers actually stopped supporting Bitcoin for payments because there simply wasn't enough supply. So I think a lot of it does have to do with the fact that if we keep building infrastructure that simply falls over after 2 years when there's a bunch of demand, that does fundamentally limit how much adoption you're going to get. Like even Solana claimed to do 50k TPS, can actually do only 2k TPS, and since it's had a lot of demand, the user experience even for simple things like payments have been terrible.
So how does it that the fee market on Celestia compares with Ethereum? I said that right now Ethereum is cheaper because there's the data that I got in the morning, but again it fluctuates, right? So it may be temporary, and like a few weeks ago it was super expensive because something happened, and like
ZK Sinclair drop.
What was that?
ZK Sinclair drop happened, so everyone was like spamming.
So we all know that the price can like fluctuate. How is price set up on Celestia compared to Ethereum? And same question for Matt. I'm not like familiar with how prices are actually set on EigenDA, and who decides on the prices on EigenDA.
Yeah, so in Celestia, it's just a standard fee market, kind of similar to Ethereum. So like right now, both on Ethereum and Celestia, blob space is basically practically free. The only difference right now is that in Ethereum, there's a much higher overhead cost to kind of like having a blob carrying transaction. So that's kind of what makes it much more expensive right now than Celestia. But other than that, the per byte cost of the block space is free. It's just that the overhead costs of submitting a transaction is higher on Ethereum.
Yeah, and on Avail also, the transaction fee mechanism is such that there is, of course, a standard base fee. But on top of that, depending on the amount of data that you want to publish, as well as the congestion that is there over a period of time, the prices are going to fluctuate. So I think it's standard fee market practices.
Yeah, I guess, and a brief mention on the Ethereum blob space. We do expect that the costs are going to go down, right? As this roadmap is continued to be implemented, we've seen that. We also have seen spikes of volatility, right? In fact, where blobs became more expensive than call data, right? So being able to have some predictable prices or expected costs is potentially useful on that front. So how EigenDA is structured is based off of the amount of data throughput that you need, right? So there are various use cases or various requirements, maybe for something that is posting proofs, might require a higher data throughput than a smaller, just transaction sort of commitment hash. So it's based on the amount of data you want to post, but also let's say market conditions. And some minimal exposure to that. But we also offer the ability for reservation of bandwidth. So what I mean by that is being able to guarantee certain bandwidth for a set price for a certain duration of time over a certain period of time. So you can have more expected costs essentially on data availability.
Talking not just that you represent Ethereum, but you're also working for Scroll. Scroll is a rollup, right? Pays a lot of, I guess, for data on Ethereum. Why?
When we initially set up to build it, we decided that we want to minimize dependencies as much as possible, third-party dependencies. So, and especially I think for a general purpose rollup, it's very important that you don't introduce any unnecessary dependencies, even if it comes at a trade-off of having a higher cost. Because if it's an app-specific rollup, let's say, and it's doing gaming or something like that, the failure of that DA provider is not as much of a big deal as a rollup that hosts potentially billions of dollars. We currently have around $1 billion bridged into Scroll. So imagine if for some reason the DA provider, the third-party DA provider, stops working at some point. That'll be catastrophic. And so we made a conscious choice to trade off a bit of transaction costs, make them higher, but make the protocol itself more secure from the perspective of being as trust minimized as possible, both in terms of correctness assumptions and liveness assumptions.
So I wanted to touch, a little bit more on that point. There was a great question from the audience in the previous talk when we discussed enshrined versus non-enshrined DA, right? Like an external DA versus enshrined DA from the point of view of Ethereum. And just to set the context, my personal understanding of what would be the enshrined DA is if you are running a full node of Ethereum, then with enshrined DA, your full node would essentially be able to check if the data was made available, right? And if there was a data withholding attack, the data wasn't available, your full node would simply see that block as being invalid. So even if the majority of the Ethereum validators would confirm such a block, your full node would reject such a block, and that would likely result in some kind of a user-activated fork, and that is considered to be super secure. On the other hand, as Sriram from EigenDA once said, the external DA looks like data availability committee to Ethereum in the sense that the Ethereum cannot do data availability sampling for external DA solutions, right? So you need some kind of an attestation, like for example, the Blobstream bridge from Celestia. So essentially, Celestia validators are attesting that the data was available, so you are not protected from the majority attack. You will be protected if you are a sovereign rollup. So my question now is, if there is enough blob space on Ethereum in the future, right, and you are an Ethereum rollup, then arguably using Ethereum DA is more secure. If you are a sovereign rollup, then arguably using Celestia or Avail or EigenDA, I'm not sure, is better because you can yourself detect that data wasn't available and that the network is under attack. Would that be a fair kind of like statement moving towards the future? Would it be fair in other way to say that if there is enough blob space for rollups on Ethereum, then it's maybe from the security point of view better for them to actually use Ethereum DA, or is there something compelling other than price to use external DA, given that the security is like slightly is different, right? There's a different security assumption. How do you guys think about this problem?
So essentially, I think I would love to have the world that black and white as you painted, but to be honest, every one of the rollup implementations have nuances when it comes to using external DA or even Ethereum DA. For example, what can happen if the sequencer doesn't publish on an external DA? Is that a trusted sequencer, which means that you always trust that the sequencer has published it? Or are there validators inside that rollup system which attest to that fact? Irrespective of what the external DA committee or the validator said, they attest or not. That is not what is the source of truth in the settlement contract. That has to be determined first. And this is a conversation that we have been having with various rollup teams right now. And each one of them has made different trade-offs. Some have made trade-offs that you optimistically accept that the transaction has been published, and you just move forward. You move forward because you just rely that it will do its job, and Ethereum it doesn't matter for Ethereum. You just trust the external committee, right? And we have seen production-grade rollups with huge amounts of TVL doing that. On the other hand, there has been designs in which we have proposed, and we have been rejected, where we wanted to have not only verification by the attestation bridge, but also verification by the validator set, because the rollup cannot handle invalid batches. It always assumes there are some rollup constructs which assumes that all published batches are correct, irrespective whether the execution attestation has been correct or not. And hence, depending on what kind of rollup you're talking about, what is the implementation there, what are the security assumptions, what are the participants that are there, who are the watchtowers, are there a need for watchtowers, is it a ZK verified, is it not, are we talking about liveness, are we talking about safety, is it centralized sequencer, is it multiple provers? It all depends on those kind of design choices. On the other hand, it's not just about the cost. The cost is, of course, one of the major factors, but it's also about what kind of orientation do you want for the application. For example, you want light client verifiability for that application. The application users want to verify the execution and the data availability. On Ethereum today, at least, you cannot do it because there is no database sampling. With danksharding, it will come. So there are also product requirements which guide this, and not just cost. So again, it's very nuanced, but happy to get more.
But just to add here, a light client that only does data availability sampling can still follow an invalid head, because if you don't verify the execution, then the execution can be invalid, and all the full nodes will drop that block, but your light client will just assume that block is correct. So even if Ethereum doesn't have DAS at the moment, no other chain that is live right now has a light client that verifies both DAS and execution, which means that you're, to a certain degree, still trusting the multi-sig of the consensus.
But you're now changing the premise. We are talking about data availability part only,
no.
And we are talking about blockchains which doesn't support too much execution, right?
But the thing is...
Hold on, I mean, your statement is also true when Ethereum supports DASing, until Ethereum supports ZK proofs of the execution environment.
Oh, but I'm not disagreeing with that. I'm not saying that Ethereum is going to have it. I'm just saying that no other chain has it either. Because even if you verify DAS right now on Celestia, for example, it can still be an invalid block. So verifying just data availability is not sufficient.
Yeah, but the point is that Celestia has minimal state, so you can run a partial node that does execute all the state, but does the sampling, which is lighter than a standard full node for Ethereum or Bitcoin, for example.
But Mustafa, I mean, in general, would you kind of like agree with the statement that external DAs are more, I don't know, useful, I guess, for sovereign rollups rather than the Ethereum rollups going forward in the future, assuming that there's an abundance of a cheap blob space on Ethereum?
Well, that's a loaded question. First of all, what do you mean by useful? And secondly, what do you mean by sovereign? Those are very controversial words in themselves, right? So,
like sovereign meaning that, you know, they define their own ordering, or, you know, like they don't follow Ethereum. You know, if Ethereum reorgs, they may like go their own way and whatnot, right? They don't like follow the Ethereum consensus.
Sure. I mean, look, the way I would put it is the following. I would say 2 points. First of all, the idea is that Celestia scales any ecosystem. So yes, it can scale Ethereum L2s or Validiums or Optimium chains. It can also scale Bitcoin L2s, but it can also scale Mina L2s, and someone is even building a Celestia DA bridge to Solana so that you can verify DA proofs on Solana. So, and then of course you have sovereign rollups or native. Let's ignore the word sovereign now because that's a very loaded word. I don't think anyone on this panel even agrees what it means. Or let's call them native Celestia rollups. Yes, you can use them for all of those things, and that's the first point I would say. It does make sense for all those use cases. And the second point, I think, look, fundamentally, the fundamental fact is that yes, everyone on this panel agrees that if you're an Ethereum rollup or Ethereum L2, inheriting Ethereum security and posting a DA on Ethereum is the most secure solution if you need that level of security. But the fundamental reality is that Ethereum, for good reason, needs to be very conservative with its technological roadmap. It can't jump straight away to 16 megabyte blocks. Right now, it's got 375 kilobyte blob space per block. Even after PeerDAS, it's not going to jump to 16 megabytes. The current discussion is that it will jump to 1 megabyte, and that's still only a few hundred TPS. So the alternative DA layers, they provide a way to have like 10x, 100x, 1000x as data throughput, while still giving you the ability to settle to Ethereum. And yes, there is a security trade-off, and everyone acknowledges that.
Anything to add, Matt, from like your camp, or you kind of like agree mostly, you know, with this characterization that we've just put forward?
Yeah, sure. I can maybe give it a little bit more color, and I agree. The use of data availability depends on your use case. So depending on what you need to prioritize, then it makes maybe a little bit more sense. If you need, like, depending on your needs, essentially, that is like, there are cost prohibitive, you know, with DA maybe on the L1 itself. But we, again, expect that to decrease. So there's not just cost that maybe is boiled into decisions for rollups or other use cases. Like, we expect that AVSs will be a consumer of DA in the future. You need to be able to publicly verify any of the data there. So the bottleneck isn't necessarily on even like the execution of like these state transition functions anymore, but it begins to also place a lot of pressure on the amount of data that you can post, the throughput that you have. And we've seen that as far as teams that are pushing extremely aggressive transactions per second, like a mega ETH, right? Where that is their focus of maximizing the amount of like transactions. And then DA becomes their bottleneck. And high throughput is then a key requirement for them, right? Not just cost, but also high throughput, as well as like underlying security. And that for EigenDA is inherited through Ethereum. So that, I would say that there are different designs require different trade-offs, and depending on your use case, I think that it's a complete evaluation. It's not like a one-size-fits-all.
Yeah, you wanted to add something?
No, I was just going to say that paradoxically, from our perspective, the biggest bottleneck on Ethereum right now is execution, cost rather than DA or anything else.
At the moment, right?
Yes, yes. So, for example, we are currently the fastest L2 in terms of finality, but the trade-off there is we pay a lot for settling quite frequently, and basically we in our next upgrade we'll add batching of aggregation of proofs for a lot of batches, and basically delay the finality further than what it is now, purely because the execution of Ethereum is prohibitive, and it's going to become even more prohibitive once rollups becomes too decentralized, because there are certain things and certain overheads that you need to do on chain, and then to add to that, once you add multi-provers and multi-verifiers, computation actually becomes super expensive on Ethereum, and so unless you have like thousands of TPS of demand, there's no way to amortize it properly. And so I think what I'm trying to put pressure on Ethereum, and like a lot of other builders of L2s are trying to put pressure on Ethereum to actually increase the gas capacity, because at the moment decentralizing and also improving the security of L2s is actually quite cost prohibitive.
Okay, now I kind of wanted to switch gears a little bit, you know, and maybe get more technical, so that certain concepts are more clear for the audience, for myself as well. Quite recently, a newish, I think, term has been thrown around in the discussions around DA. The old term was data availability sampling, DAS. You know, like people say DAS, you know, you should probably know what is data availability sampling and what is its role. The newer term is VID. I had to check it, you know, a few weeks ago. I think it stands for verifiable information dispersal. And I believe that this is a technique used by EigenDA to disperse data amongst, you know, different validators. Today I've heard that Celestia wants to do sharding to achieve, you know, a bigger blob space. On the other hand, dunk sharding also in the future will not require full nodes to download the full blob, just a portion of it, which is, by the way, the case, I believe, in Celestia right now, and indeed the current Ethereum for 844. I'm not really sure about Avail, frankly. Can you, like, guys, sort of set the stage for these concepts? Are we talking about completely different things, or, you know, or these are like similar techniques in a way? And yeah, what is this, you know, like VID, the verifiable information dispersal? Maybe I'll start with Matt, and then let me hear from Mustafa if this sharding is the same thing or not.
Sure. That is, I mean, verifiable like information dispersal. Like, personally, I think that's less of maybe like that is an aspect of the architecture, but less of maybe directly related to like data availability sampling. Like that is more so on to give a little bit of context as far as how it works. And when I mentioned it's like inspired by dank sharding, essentially you have a blob, you have amount of data that's sent, it's chunked into blobs and dispersed amongst a network of operators. These operators are AVS operators in the case of EigenDA, and they secure like proportional amounts that they have staked. Essentially, you can only secure the amount of data that you could possibly safely and securely do so. So the dispersal is this sort of portion that goes from dispersing to those operators and ensuring that it is dispersed. But the data availability sampling is a separate aspect, and ensuring that once, you know, it's a different problem to have it dispersed than to make sure that it is available. And that's, so there's like two different sides, right? Is being able to ensure that that data is then made available after the fact and not necessarily just dispersed and dispersed, you know, forever. So if that distinguishes,
that sounds about right. I think, yeah, this is I think you also talk about something called proof of retrievability, which is a very old concept from like the early 2000s that is very similar to data availability sampling. It's just that the main difference is that proof of retrievability and verifiable information dispersal proves to you that the information has been dispersed or to some servers or can be retrieved from some servers, but it doesn't actually prove that's actually being published to the internet such that anyone can actually download it. But to answer your question about the sharding, yeah, I mean, you brought up the point that like with like, for example, like dank sharding roadmap, the idea is that consensus nodes or block builders or validators, they don't have to download the full block to verify it. So it is the case that in Celestia right now, you do have to download the full block if you're a consensus participating node to build on top of it. And the reason for that is because Celestia relies on bad encoding fraud proofs, whereas dank sharding uses KZGs to prove the correctness of the erasure code. And because we use bad encoding fraud proofs, there's this like 5-minute or 10-minute fraud challenge period. So obviously validators cannot wait that long to build on the next block. They only have 10 seconds, right? So I would say two things to that. Like, first of all, I'm skeptical of the scalability advantages of making it that validators don't have to download the full block to build on top of it. And the reason for that is because that only makes sense if you assume a perfectly distributed staking setup where like they have 1,000 different validators and they all own 0.1% of the stake each, such that they're perfectly uniform. But what happens in practice, and if you look at Ethereum today, there's 3 validators or a small number of validators that control 2/3 of the stake or most of the stake. And so what happens in practice is that most validators that actually control most of the stake have to download all of the block data anyway. Where this is advantage, where this does have provide advantage is for like home stakers that have very little stake. The home stakers don't have to download the whole block. But I'm very skeptical in the first place of optimizing for thousands of home stakers instead of optimizing for a Nakamoto coefficient that makes sense. For example, like in Celestia, we have 100 validators, and then having fast, immediate finality, we have 10-second finality, for example, instead of optimizing for thousands of validators when the Nakamoto coefficient is very small anyway, and having 5 minutes, much lower finality. But the second point I would mention is that we do actually also, as you saw in Ismail's roadmap talk, we do actually also want to and have plans to ZK prove the correctness of the erasure code. But our current thinking is that we want to skip straight to seeing if we can Stark prove the erasure code rather than using KZGs to do so.
But would you be equally skeptical of the current EigenDA architecture? Or,
yeah, I'm also skeptical of that for the same reason. I know that EigenDA claims that you can scale the number of nodes, but again, that's only the case if you assume a perfectly uniform number of distribution of stake across 1,000 nodes, which we've never seen in practice.
Sure. EigenDA doesn't have consensus on top, so there is no like concept of consensus within EigenDA. It is a data availability layer, so in the fact of this data is dispersed to operators that is made available so that full nodes, if required, can retrieve the data to ensure that the state transitions are made. So I guess that's like one point just of clarification, that there's not additional consensus for full
we're
nodes.
talking about the data availability nodes. We're talking about like you're dispersing the data to 1,000 nodes, and the more nodes you have, the more data you have.
Yeah, and the operators of a data availability layer aren't also ensuring the correct state transition functions. Those are on the services that would require use, right? So correct me if I'm wrong, but the rollups that are using this data availability layer would retrieve that data, and if required, would also download that to a full block, full node rather, and ensure those state transitions, let's say, were made correct. And there's different,
No, but the argument that I'm making, or that Bartek is asking, is that the scaling story for EigenDA is that you can scale with number of nodes, right? So the more nodes you add to the network, the more operators, the more like validators in this AVS, in this EigenDA AVS, the more data throughput you have. But what I'm saying is that that only is true if you assume, like if you're saying you have 10 megabytes per second with 100 validators, then you have a gigabyte per second with 1,000. I'm saying that's only true if you make the assumption that yeah, exactly. It's only true if you're making the assumption that the stake is equally distributed to the 1,000 validators. When in practice, what will happen is 10 validators I think it is the case right now. Five validators in the EigenDA AVS control two-thirds of the SIG.
Plus, all of this, plus there are many more nuances which we are missing. Like the disperser right now is centralized and it is able to send 10 megabytes per second, as they claim. And with 1 Gbps connections and such, it's yet to be seen, like with thousands of operators, what is the requirements for this disperser first. Then there are other things also, like we are talking about two very different kinds of systems here. One is consensus driven and the other is committee driven. And if you take a look at the protocol level guarantees that both of them provide, they are different. And not only from the protocol level, the protocol participants, but from the user level, the requirements are very different. For the data availability sampling, it's about the user level guarantees and not the protocol participant guarantees in that sense. Because the data availability sampling says is that I do not want to rely on whoever that is. But the verifiable information dispersal, that is about how does the information get dispersed within the protocol participants. And they are kind of different things. In terms of, like, I think a lot of different concepts were covered, but in terms of stake distribution, there is problems with that because the incentives are not aligned correctly. In my worldview, I think like the delegated proof of stake and the concentration of stake are kind of related, right? Because if the incentives are not there to delegate in the least staker, then it's there to be seen what is happening, right? And that's why at Avail we are trying to do nominated proof of stake. We are trying to do fragment in a bid to make things much more decentralized, the Nakamoto coefficient to be much higher. And yeah, I mean, that's why there are many different topics. Each one of them should be discussed separately, and only then we would be able to talk about the differences and the deltas.
So before we run out of time, there's just one more concept that I wanted to clarify, which I think is enormously misunderstood, and that is a proof of custody. It was like introduced a while ago by I don't know who, but Dankrat defined it as a technique to prevent what he called lazy validators. Validators that wouldn't download the full block because it costs time and money, but they would just attest, right? So that would be like a crypto economic or a cryptographic technique to make sure that we don't deal with lazy validators, but this is certainly not any type of like guarantee that the data is being stored or held by the validator or whatever, right? So it was just a technique that the data was actually downloaded by the validator before a testing. And then EigenDA kind of used this term, I think, for something else, if I'm not mistaken, at least a year ago. Now it seems like, this concept maybe is forgotten. I'm not really sure. I just wanted to sort of like, clarify, like, what is the current thinking in EigenDA team about this, concept of proof of custody, which was like heavily marketed a year ago, and now I'm not even sure if that's the thing. So have you guys like changed your mind about this, or like what's the story here?
Are you speaking to the fact of like operators being able to like attest to the fact that they have data, or what is?
Yeah, I mean, that was the concept that, like EigenDA was like pushing, and slashing condition was also like defined on that in one of the test nets, but I think it's not on the mainnet. So I'm kind of a little bit confused, and I just, wanted to get from the source, like, what's the story about the proof of custody here? And also the question to other guys, if this is something actually like important in your opinion?
Sure. Yeah, I'd say, I mean, it might like still like be a piece of like the along from like dispersal to like data availability sampling, there's like still a requirement to be able to have attestations from those operators to ensure that it has the data. But I wouldn't say that it like the architectural like design as far as implementation on like slashing conditions for data availability. You have to be very cognizant of the fact that there are different things at play that a proper actor can still, like if you just solely say, hey, do you have the data, and you don't receive a response back, that does not necessarily mean they're acting maliciously. In fact, that's like possible that they could be getting like DOSed, essentially, that they have too many requests to respond to. Essentially, they don't have the ability. So more so speaking to the fact that there are other things that you have to be very careful about, like these slashing conditions, and custody is like an aspect of it, and like how you are able to ensure that you can retrieve data that has been dispersed.
Mustafa, a quick take, and we have to wrap up.
Yeah, I mean, I think it's pretty clear, like proof of custody does not provide you with data availability guarantees. It's more like a nice to have, or like if you can't do data availability, then custody gets you kind of like maybe something, but it's better than nothing.
I mean, again, we are talking about different kinds of guarantees within the protocol. If the guarantee that we want is on the dispersal, then that's one. It's about retrievability later, and you want to prove that within the protocol, then there are proofs of retrievability that are there. You can have to play challenge response mechanism there. If the end user wants guarantees, it has to do sampling, because that's the efficient way to do it. And after 18 days, after 20 days, if you still would want to have guarantees, you have to play a fresh round of challenge response mechanism and not rely on original attestations.
Toggle, last chance for a controversial take, and we're wrapping it up.
Just use Ethereum.
All right, thank you guys. Thank you, the panelists. I hope that it was as entertaining as it was to me, and thank you so much, guys. I hope you see you next year.